All right. Also, cross-cutting concerns when you have a single hub for every button that a user might click in your Blazor application or everything that happens, then you can get a lot of telemetry for free, which we'll show you in a little bit. But if you just have a class like on the screen, record call, and this code is actually taking one of those objects and pulling all the properties out of it and turning it into a application insights custom event, and then pushing it to application insights. So now we have an application performance monitor tool that is recording literally everything that every person is doing in my application. And whether it's Datadog or Splunk or, all the products are so good these days, but just this pattern allows you to do it, because instead of a button on a particular screen calling a method call, which calls a method call, calls a method call, and then you have to instrument everything, if you have every button on every screen, route every query, command, or event to the same hub, routing through the same pathway, well, now you can implement these cross-cutting concerns, and this code can sniff and inspect and gather data from everything that goes through it. And it's a really magical pattern. Okay. Another thing for Blazor WebAssembly specifically, Blazor WebAssembly is one web service. All right. Now, I don't have enough time. I've done dedicated talks on this, gone through the pattern. I don't have enough time to actually dive into it because it's a whole hour long. It's a whole hour long session just in and of itself. But I've included a URL to a GitHub repository right here, and actually, the Programming with Palermo video episode that I highlighted at the beginning, which I'll show you again at the end, is actually episode, I forgot what episode number, but it is a full walkthrough of the code for Blazor WebAssembly with a single web API. Here's the problem statement. The default pattern for Blazor WebAssembly is that you have a page that needs some data, and so it calls a web service, and then you have a web API controller on the server, and it might get some data or do something interesting. Then you have another screen that needs some data, so it calls to another web service, which is another web API controller, which does something. And then screen number 4, 5, 6, 7. Okay, so you get the gist. We get to real applications that have lots and lots of screens and lots of reasons for needing data or needing to process transactions and send some signal to the server. And we end up with a whole lot of web services. Now, if you have a web services SDK and you have web service customers and you need that, well, that's great, because then you layer on Swagger UI, you layer on authentication and security tokens and everything that's necessary to manage public web services, and that's great. Web services are great, but wait a minute. Now I have an application where I have no intention of publishing these web services for any other third-party use. These web services only exist because my Blazor web application needs some way to call over to the server. I really don't care how it calls over to the server. Built into the box is a way for it to do with web services. So, okay, I guess I'll use that. But architecturally, I don't care how it calls to the server. I just want it to work. I want it to be fast, and I want only my application to be able to call in. And I don't want anybody else to be able to get into that pipeline. So the default pattern, though, kind of pushes us to web service sprawl. I have a ton of web services that now have to be maintained for no value of that maintenance. Okay. So instead, don't do that. Instead, steal the pattern from the Azure Service Bus SDK. And it's not a new pattern. In-Service Bus has been doing this for forever. RabbitMQ, Azure Service Bus, SignalR, the SignalR SDK does this. Heck, SQL Server does this. And that is the concept where, in order to talk to the database, or in order to talk to the server, there is one connection string. There is one address. There is one address to a queue. And so in doing that, you send multiple message types to that address, and then the server on the other end knows how to sort it out. You can send an infinite number of queries to a SQL Server database through the same connection string, and the SQL Server engine knows which tables to go to and how to sort it out. And so go through this code, and the video is a interactive demonstration of that. This is not slides. This is code and demonstration. So there's a video on programming with Palermo where you can where I walk through and talk through it all. It's really interactive. This is not something that you can demonstrate well just by looking at slides. But in doing so, you could have 100-screen Blazor WebAssembly application, and every button sends a command or a query or an event to a bus, and then the bus hops it over the wire through a single web service, and then out on the server, it routes it to the appropriate handler that can get the data or process the transaction or whatnot. So if you are using a Blazor WebAssembly application, then look at this pattern. Don't just go whole hog into using the default pattern out of the box, because you're going to end up with tons of web API controllers for no benefit of the maintenance overhead that it's going to create just because you have so many of them. And you never intend to support them as published parties anyway. So you're not going to layer on Swagger and all this other stuff. You only need one. You only need one way to jump over the wire and get to the server.